Okay, good afternoon, everybody again. So today we will begin to learn econometrics by starting from the simplest version of model. We call it simple linear regression model. So simple means uh, just a moment. Simple, yes. Okay. Okay, so the simple linear regression model. So simple came from you have only one explanatory variable. Suppose we want we would like to find the relationship of price and quantity. You may learn economic theory and then you collect the data of price and quantity and get the data similar to this. Okay, X is price and Y is quantity. After you collect the data, what to do next? What to do with this kind of information? How can we find the relationship between price and quantity? So I firstly recommend you to plot the data first. Okay, so from price and quantity, you have plot the data together. So the y-axis is y, x-axis is x. So x equal to y equal 4. So dot. Next, x equal 3, y equal 6. So 3, 6, dot. 5, 9, dot. 6, 14, dot. 9, 17, dot. The type of this plot we call the scatter plot. To show the relationship between two variables. And then after you plotting the data, you may familiar with this chart. Oh, since price and quantity is a slope upward, wow, this will be a supply curve in economic theory. So this data look likely to be the supply curve, which means the higher price, the higher quantity they want to solve. So the higher x, the higher y. Wow. So after we collect the data, we found that oh, this data we can produce supply curve for us. It means if build, we can build a linear line to represent the data. You can finally construct a supply curve. So the process that make the line to represent the data we call regression. Okay, so regression analysis is a process for estimating the relationships between dependent and one or more independent variables. Okay, and among a lot of methods they have, this is the most famous method we call ordinary least square. So we take O, L, S. Okay, so after you plot the data and okay, we would like to know the relationship between two variables, then we try to make one line. And to do one line, we call it regression analysis. With the most famous method, we call it ordinary least square or OLS. So what does it mean, ordinary least square or least square method? Okay, let's start from this chart. Okay, the blue dot is the real data that we plot together, right? Previously, we try to plot, oh, we collect the data and plot, oh, this is the supply curve. So blue dot, each of blue dot is real data. But actually, when you make a line, the data that on the line is the forecast data, right? Forecast, the blue dot is actual or the real data. So the difference between actual data and forecast data, we call it error, which we put the hat on it, which means this is the calculate error or forecast error. Okay, so hat means you predict it or you forecast it. So least square method, for example, if we assume that the relationship of y and x is like this, y equal intercept plus slope multiplied by x plus error because this will be a econometrics, which means if I draw the figure, we have the beta 1 here and we have a beta 2 at slope. This is x, this is y. This is the meaning. However, previously we collect the data of x and y, right? That we brought it together. So we know y already, we know x already, but we don't know beta 1, beta 2, and error. So the best we can, so we try to estimate them, estimate the closest relationship between y and x. So instead of beta 1 and beta 2, we try to estimate it. So we get beta 1 hat and beta 2 hat. So this line, the dot line, is this equation. After we put each x, for example, if x equals 6, the real data is 14. Here, 6, real data is 14. But the model or the forecast line said that, oh, the predict is 12. So error, the estimate error, the predict error, the error hat equal the difference between actual data and forecast is 2. Okay, so this is the meaning. Then if we would like to write y, not y hat on the left, it means you have to plus error on the right hand side. Okay, so you can write down two ways. First, y hat without error, or you write down y, but you have to plus error hat. Or it means, this is my language, sorry. Or the actual data equal the one you forecast plus error. And then okay, that the least square method. Previously, I said that, okay, the method they use is called ordinary least square. Least is mean minimum, right? Square is, okay, is square. So what is minimum square? They try to minimum the thing called error. So the method, they would like you to find the best parameter, beta 1 and beta 2 hat, that minimize the sum of squares of error. So they minimize sigma error hat square. Okay, and then they insert this data for y hat equal to beta 1 hat minus beta 2 hat x, and then use the optimization, which you do not have to serious, just to know the background of this. Do not need to solve any mathematics. You can believe them. Okay. Oh, they are correct. We no doubt about it. But this is the method behind. They try to minimize by, okay, take the first step, make it equal to zero. Take the first step, make it equal to zero. So you have two data, you know, y and x. You would like to find beta 1 hat, beta 2 hat. So two equations, two parameter, we can find beta 1 hat and beta 2 hat. That's all. We will not do a heavy mathematics today. Okay, just to know the method behind this. And after they solve a heavy mathematics, oh, this beta in the finally, this is the final result of Thai again, sorry. Okay, so this is the least square method for simple linear regression only. Simple means you have only one x, okay? And actually, you do not need to remember. In my exam, I will allow you to open my hand out. So do not need to remember anything. Just understand it. Just understand it. So after they solve a lot of this equation, y hat equal beta 1 hat plus beta 2 hat x, they finally get, oh, if you would like to find slope, this is the equation for slope. So sigma x minus x bar y minus y bar over sigma x minus x bar square. Oh, professor, this is too complicated for us. And then, okay, since it's too complicated, I will help you. So given x minus x bar, because it's too complicated, I will write down as small. Okay. Instead of capital X minus X bar, I will use small x to represent this one. I will use small y to represent this one. Then slope equation become sigma xy over sigma x squared. This is better? No. Still difficult, huh? But later we will do it together, okay? And then we find out that after we can find the slope and we put the data here, we can also find intercept equal y bar minus beta 2 hat x bar. So I promise you, only today we will calculate this one together just for understanding. Okay, later we will use program to deal with it. But you may doubt that, oh, how program calculated y is become this number, something like that. So let's try once and you will understand it forever. Okay, so only today. So let's do it together. But since we are in the computer room now, I will allow you to use Excel. Okay, so in the Google Classroom, I already attached the Excel. So please open the Excel file of this data. Simple regression.excel. Go to the example one. So first, wait. So first glance of the data. This is the data. For example, if you collect the data and get X and Y, and you would like to estimate the relationship between these two. Okay, so what will you do first? I highly recommend that after you getting the data, let's try to plot the data first. So to plot in the Excel, select all the data like this. Select all the data. Uh, I cannot read, but I think yes, and then download. Okay, okay. And then example one. Yeah. So I think you have to open in the new window first for the this one that's okay. So you go find and download it. Oh yeah, yeah, yeah. So of course, of course. Yeah, fine. Yes, download. No, no, no. You can download. Yes, so Excel is better. Yeah. How about you? Oh, it's okay. Now, open the Excel is better because the window view similar to what I use now. Okay, so I first after you getting any data and you would like to know, okay, what is the relationship between whenever you get that between two data. Then you select y and x first, select all the data, select the data by and select right click right click, that's right, left left click and drag the data, something like this. Okay, select all the data. Okay, good. Select all the data and go to insert tab, insert tab, and then click on recommended charts, recommended chart. Yeah. Okay. And let's find scatter plot. Go to all chart. I don't love this one. Okay, let's try again. I don't need line. I need just a dot. Just the plot. Yes. And let's open it first. This is available. Okay. So click enable editing. Enable editing first. Yes. Okay. Select all the data. Yeah. Go to insert. That's by insert. Left click. Okay. Insert. This one. Insert. And take comment the charts. Okay. We show you. Okay. Insert. Like comment the chart. But I don't need the line. I would like to change to scatter plot. So click all charts. Then go to XY scatter. Okay, all chart XY scatter. And then I think you need to choose the second one. Yeah. And then click OK. Uh-huh. You get, oh, good. Yes, good. Good. Okay, so this is actually what we have done together using your hand, right? But actually, in the real world, when you work with the real data, you can use computer program Y. Why we need to plot it by yourself, right? But okay, you can find the relationship between these two variables. Okay, they are somewhat positive relationship of each other. If we can find the line to represent this data, it would be good. So we try to make this line together. Okay, we try to make this line together. So this is the, okay, you delete the chart first or make somewhere else. This is the equation you need to make the linear line. And they gave you the formulas here. This is how to use find beta 2 hat. This is how to find beta 1 hat. What shall I do? Hit it. Okay, step by step. First, they have X bar and Y bar on the formula, which means you have to find average first. So if we calculate the mean, we will get X bar and Y bar. How? So first, let's sum all the data equal sum of all above data. Left click and drag the data. Slowly, no problem. Okay, let's start. Yes, good. You can do it for Y also. Good. Okay. Click yes. equal sum SUM and open bracket. Yes. Uh-huh. Yeah. Oh, thank you. Good. And then to find the mean is average. Okay, so you can do it. There are two ways to find mean. Okay, first, if we calculate, if we count the number of observation, and okay, we have 1, 2, 3, 4, 5 data. So n equal 5. It means if you would like to find average, you use okay this number over n is mean. This number over n. Yes. Or if you would like to work it effectively, you can use equal average. Yes, equal average of all 5 number. Yes. Do not choose sum. Just choose the number that the 5 number that we would like to find the relationship of each other. So this is x bar. This is y bar. And then in the formula, they said that, okay, you have to use yi minus y bar, x minus x bar. What does this mean? It means each of y, you have to minus it by 10. So here, minus by 10, minus by x bar, y bar, minus by 10, minus by 10, minus by 10. So y minus y bar equal 4 minus 10. Yes, good. And do it all, do it all. So minus 6, you can copy the formula here, okay? So or you minus 10. And then please sum. This will become sigma y minus y bar. Let's try. What will it equal? Sigma y minus y bar. So equal sum of all data become 0. Okay, so first knowledge that you have to know is that sigma y minus y bar always 0. If you use any data minus by the average and sum them all, the value will equal 0. Next, we have to do x minus x bar. So x is here, x bar is here. So it means all the number you have to minus by 5. Okay, so 2 minus 5 is minus 3. 3 minus 5 is minus 2. 0, 1, 4. And again, the sum equal 0. Mhm. And then in the formula, they would like you to calculate sigma x minus x bar square. So you use here to be square and then sum. So if this formula is A over B, this is the B part by make x minus x bar square. So for example, minus 3 will become 9. Minus 2 square 4, 1, 16. Okay, so this is the formula. You use the left cell power by 2. And then you use sum. Okay, I will help you. Equal this cell E uh, uh, just click. Okay, and power, yeah, 2. Okay, enter. Yes, and you can copy the formula. Okay, to copy the formula, go to this cell and go to the corner one, on corner of the box. Click on the number, go to the corner one, no. Click on the number, slowly, click okay, and let's do it again. No, this is your friend do it for you. Let's do it by yourself. Okay, good. And then sum it. Yes. M. Yeah. Okay, all the data. Good. Okay. That's okay. Um, you might say that to tick. Okay. Next step. Okay, you get a B part already. Next A part, they would like you to x minus x bar, y minus y bar. So I shorten this to be small x and y. So it means you have to use this cell, okay, this cell and this cell together, and then sum it, you will get a part. So equal x minus x bar multiplied by y minus y bar here. And then do it for all and sum. And then finally, you use A over B. So A over B. Okay, then you get beta 2 already. And then to find the beta 1, they need you to use y bar. So equal y bar minus beta 2 hat multiplied by x bar. Yeah. Okay, I will help you. Okay, so D7 over, okay, enter. And you have to find the first one first. The formula is gone, right? That's okay, that's okay. So let's find the first one. Yes, yes, so this one over this one. Yes, just delete it first. Go to this one first. Okay. Yeah, yeah, yeah. So, yes, over, yeah. Okay, this is the slope. And then to find the intercept, equal y bar minus, okay, beta 2 hat, yes, multiply x bar, x bar, x bar, x is here, so x bar is here. Yes, I mean, yes, x bar because bar. Okay, so equal, y bar is here, okay, minus slope, multiply, star, x bar, and the mean, average, x bar, yes, we call this x bar is mean average. This formula is incorrect. This formula is incorrect, so you have to use sum over the number of, yes, it's mean. Okay, yeah, good, all right. Yes, it depends on the version because you didn't download it directly from the, you used to go to Google Sheet and then convert to Excel. That's why it's gone. Yes, yes, yes. But that's okay. It's the process of learning. No problem. Okay. Oh, very good. So what does it mean? You finally do the regression. And then after you have two data and try to plot this figure, you finally get that, okay, your equation now is y hat equal intercept the beta one, right? Plus, okay, just 2 digits, right? X. So this is the meaning, okay, for 1.93. We estimate that if X go up by 1 unit, okay, we estimate that if X go up by 1 unit, Y will increase by approximately 1.93. This is the meaning of slope. X increase by 1, Y will increase by 1.93 approximately. How about this number? This number means if X equal to 0, Y will equal 0.33, the intercept. So this is the meaning of intercept and slope. Okay, so we will try to make a forecast Y together in this column. So this is Y hat. How? How can we do it? So you put X on this equation. For example, here X is equal to, so Y hat equal 1.33 plus 1.93 multiplied by 2. Or in Excel, you can equal the intercept 1 plus the slope 1 multiplied by X. Do it again. Equal intercept 1 plus the slope 1 multiplied by X. Do it 5 times. Intercept plus slope multiply X. Intercept plus slope multiply X. Then sum it for me. Sum all the y hat for me. And calculate the mean. Do sum and calculate mean for me, please. Hmm. Let's check again. Sum to, oh no, all the number is correct, but the final then is okay. You like of one data. Good. Okay, then sum them. Yes, all the data is correct, but the formula may be incorrect. Just the gray one, you have to use sum, equal sum. So I can show you here that by doing it together, we can see that, okay, y bar here equal 10, right? This is also 10. And it's away true. So y bar equal to y hat bar mean average, always, any data. And this is how to read the data. If x equal to the real data is 4, but the forecast, our model forecast is equal 4.2. Okay, again, if x equal to 3, the real data is 6, but our model predicted 6.13. So they all have a small error, right? They have a small error. So we then calculate the error here. So error is y minus y hat. So the first one equal the real data minus the predict one. Okay, the real data is 4. The predict data is 4.2. So the calculate is error by minus 0.2, a small fraction. Then real data is 6, but our forecast is 6.13. So again, we have a small fraction of error. Okay, error, error, and then error. And then again, sum it for me. Okay, you may not familiar with this one. So this is e minus 15. It means 0 plus 0, 0, 0, 0, 0, 0, 15 times. Okay, so I highly recommend you to go to the Home tab and then click on the number here. Click as is 0. Okay, the real data, yes, minus the one we forecast. So that's we call error. Enter. Sorry. Okay, and then copy. Now we have to go to the corner. Yes. Then we slowly. Yes, and then sum it. Yeah, yeah. Okay, and then click on this cell because we have e minus 15. What does it mean? Click on this one. The second one. Yeah. Okay, good. Okay. So this literally means 0. Okay. Okay. So click. Okay. Good. Good. So what does it mean? I do prove it for you. They have one thing called sigma. Oh, I would like to change it to red. I love the red one. Yes, sigma L hat equal zero. Okay, make the box for it. Make the star for it. It's very important one. Sigma means sum. Hmm. Okay, so sigma is, for example, if I write down sigma error hat, it means you sum all the error. So error 1 plus error 2 plus error 3. So we write down sigma. This is the meaning. So here we calculate each error and then you sum it together. Okay, you sum it, sum, then you get, okay, sigma error hat is zero. What does this mean? It means total error is zero. Zero. It means overall model error is zero. It means the model is in the center of data. Oh, to make the overall error become zero, no error. Okay, they may have the positive error, they may have a minus error, but overall, if you sum them all, total error overall in the model, the forecast error is zero. And if you calculate the average, it means average error is zero. It means if you get the figure, if you have the figure, you try to draw one line that through the center of the data to make sure that, okay, overall error is zero. Make this line to represent the data which overall error equals zero. This is the method. And you know the the method behind this? Okay, so after you get the data, they try to make a line, one line that, okay, this will represent this data, which this line will make overall error 0. And then let's try to calculate this one. Error hat square. Error hat square. Okay, so this is error hat. So to do error hat square equal this one square. Okay, after you make all square, please sum it for me. Oh, damn. Okay, so this is error hat square. So you use this one square to become this one. And then this cell will represent sigma error hat square. Good. Okay, let's delete it. Okay. Sorry for this one. Oh, good. Okay. So this number previously we call OLS, right? OLS means least square. What is least square? So they claim that their method they have the minimum of this value. So least square means they have the least error at square. So they claim that their method can produce this one at the least value, the minimum. That's why they call least square. Why? Why is so important? Later, I will show you. Okay. But when we talk, okay, this is ordinary least square, OLS. Okay, this one that they try to minimize. Okay, so we know that sigma error hat equals 0 and sigma error hat square is the least. And before we break, let's try the final cell x e hat. So equal x is here, x multiplied by e hat. X multiplied by e hat. Do it all and then sum. Oh, it's become complicated. Just delete some text. And then sum it. Okay. And you will get the zero number again. Okay, so before we break for a while, so I will summarize what we find so far. Okay, first, after we have the data, we try to plot the data and build the line we call OLS. Okay, and then we can find beta 1 hat and beta 2 hat. And then I show you that we can find y hat, and then we can calculate error hat by make a difference between actual data and forecast data. And then we do it together and see that first sigma error hat equal to 0. Overall error is 0, no error. Second, we have sigma error hat square is as the least data. And lastly, we show that sigma x and error equal to 0. Okay, you may very tired now, so maybe break for 15 minutes and then we back to learn another part of this chapter. Okay, so we will back on 3 p.m. Okay. Okay, so hope you refresh some your brain because you'll be calculate heavy mathematics, right? Actually, this class, after this class, I have record the video already. So after finish the class, later on, this lesson will be in the YouTube, on the YouTube. And then I will post the YouTube in our classroom group. So when you do the homework or you would like to review, you can watch it again. Okay. But since last week we used MacBook and I don't know how to deal with it. So we will have a YouTube video starting from this class. So last week I didn't record. Okay, so you can see that when you use a econometric to forecast to make a line for you, they have a thing called error. Okay, so error is really important in this subject, and this error, the purple that I highlight, this one will make this subject difficult. If we do not have to learn about error, okay, you finally can forecast this. You can find the slope. You can find the intercept. You can make the forecast. Wow, this subject must be easier. But since they have an error and they have a lot of assumption under this error, so that's why error here is very important. So error, some textbook they call disadvantage, some textbook call error. Okay, if you go to read some textbook or some research, they may use mu. Okay, but my style, I will use e, error, but actually they are the same thing. As you can see, not all data falls on a straight line since we have error. So that's why we call the econometric model. Why? Why error must be in econometric model? First, there may be other variables that influence the dependence variable but not included in the equation. For example, we try to estimate the supply curve and okay, you may say that the quantity must depends on the price, but in the real world, the quantity not only depends on price. The quantity may depends on other variables as well. For example, previously we caught a pandemic, COVID-19, right? The sale may be shipped down or maybe fall because of COVID-19 as well. So there may be other variables that affect quantity of sale but not include in the equation. So we call it error. Second, they have an uncertain behavior. Okay, so someday you may love to eat sushi. Someday you may love to eat a steak. Okay, so the behavior changes over time. So uncertain behavior make it to have error in the model. And third is the errors of measurement. It means this is the measurement error, nothing. So all of this, we must suggest that errors must be random variable. Error is an important variable that determines how good our econometric model is. That's why they have an assumption on error here. So this is the basic assumptions of error in the simple. Okay, simple means only one x. And this is very important. There are 6 assumptions. First, the value of y for each value of x is this one. So, oh, professor, what does it mean? So, verbally, it means your model is correct. Y only depend on x, not z, not x square, x cube. Your select model y equal beta 1 plus beta 2 x is the correct model. Assume, because this is the assumption. Okay. Second, expected. This is called expected, which means average. So expected error equal to 0, or error has an average equal to 0, which we already did it together that, oh, this one is 0, right? That means average is 0 as well. Third assumption, variance of error equal, this is sigma square. So it means error has a constant variance. Just know the word first. Later I will show you what does it mean. Error has constant variance. 4. covariant error equal to zero. It means error has no relationship between them. Again, just remember the word first. Later, I will show you what does it mean. Because if you would like to understand this time, it will become very complicated. Uh, Later, I will tell you. Sorry. 5. Covariant error x is zero. So it means error has no relation with x. And lastly, error is normal distribution. So this is a normal distribution. Okay. Error. This is how to read and very important. If you find some sentence right written similar to this is how to read it. Error has error is normal distribution and the average is zero, which have a constant variance. Okay, this is the assumption of the model. And then here comes one econometrician called Gauss-Markov theorem. Gauss-Markov theorem said that under the assumptions 1 to 5, 6 is not necessary. So error didn't require to be normal. Under assumption 1 to 5, the OLS estimators have the minimum variance of all linear and unbiased estimation. They are the best. So this is best linear unbiased estimator. So I pick B, L, U, E, blue. So shortly, we can say that OLS is blue, the best. They are the most accurate model in the world. No other can compete with this method. Only if assumption 1 to 5, previously assumption is true. Why is the best? They claim that first is linear. So the dependent variable is assumed to be linear function of variables specified in the model. Okay. Second, unbiased. Unbiased is mean expected. So beta 1 is the forecast, right? Expected beta hat equal to beta is mean averagely the forecast beta will equal real beta. It will accurate the forecast data equal real data averagely. This is unbiased. You may forecast some beta too low. You may forecast some beta too high, but averagely, since it's called unbiased, so it will close to the true data, the real data, but this is called unbiased. And then what they claim is that they have the minimum variance. Or estimator is an unbiased estimator that has the lower variance than any other unbiased. So it means this value they have the lowest of this value. So error is the difference between actual data and forecast data, isn't it? And then if you make an error to be square like this, it means it's volatile. How can I write it? This is volatile. Let me check the vocabulary. Volatile. Okay. The volatile, the fluctuation. Okay, the fluctuation of the model. They claim that this method, OLS, have the least fluctuation. Okay, imagine similar topic, huh? Not this one. Imagine that I go to interview the reporter. Okay, doctor, what will the GDP growth of next year? So first I say, GDP next year must between minus 10% to 10%. This is reliable? No, right? Reporter may say, okay, you can go home now. I don't believe in you. This is called too much fluctuation. Okay, but if I say, okay, GDP next year must between 2 or 3%. This is less volatile, less fluctuation, and this is more reliable. Again, so error hat square is the fluctuation of error. If we can get the least fluctuation of error, it means your model can forecast it accurately. Very good model, right? And they claim that, okay, they are the least or they are the best. Blue, best linear unbiased estimator. No model can compete with OLS, they claim. Okay, and why is it important? Okay, so after you get sigma error at square, here, which they claim that this is the lowest, right? The lowest value, the least error square. So this is the variance of error. So variance of error in case of simple equal this formula. So sigma error hat square over n minus 2. Since this one is the least, variance is the least as well. Okay, so previously we calculate sigma error hat square equal 5.87 and is 5 over 2. If you try to calculate it, you will get that variance of error is 1.96. You can try it. And then please follow to read this one together. To read this one, beta 1 normal distribution, okay, have the average equal beta 1. So this is unbiased. Average of beta hat equal real data, unbiased, and have a constant variance. So this is variance. This is variance. And then you may see that this is the value of error hat. So after you calculate this one, you can put them here. You can put them here. And they claim that this one has the least value, the least fluctuation. Then this also the least. This is also the least variant, the least variant. Okay, you can try to calculate it on Excel. Okay, you after you get this number, you can also calculate this standard error. So SE is standard error equal square root variance. So next page, they have a step-by-step calculation. Okay, this is the answer. Okay, so for example, variance error is 1.96. If you use square root variance, you will get 1.6. Okay, we still have time, so let's try to do it on Excel. Okay, so we get sigma error hat square here. So to calculate its variance. So E, oops, var E equal this number sigma error hat square over bracket. We have five data, right? 1, 2, 3, 4, 5, 5 data minus 2. Good. And then you can get standard error equal square root. So S Q R T. So this is square root of above number. Okay. So this is the correct answer. So forget previously calculation. I may make a mistake. So forget this one. Not 1.6 is 1.4. Yes. I forget the answer. Okay. And then, okay, let's see the formula and try to calculate variance of beta 2 and variance of beta 1 because I see the homework and I put the homework that you have to calculate both variance error, variance beta, and standard error beta. So let's do it together in the classroom. So when you do the homework, you can back to watch it again. Okay, I already recorded, so I will post in the Google Classroom, and then when you do the homework, you can watch along and, and try to answer me. Okay, so I will put the formula here to see because I never want you to remember anything. Okay, just to understand. So me either cannot remember the formula. Okay, so the key point is you understand it, not remember it. Okay, so this is the formula. Okay, let's start from beta 2 since it's easier. So this one is variance error. This one we already calculate. So this one is x minus x bar square. So x minus x bar square here. So here. So variance beta 2 equal variance error over this one. And variance error over sigma x minus x bar square. Okay. Then to calculate standard error, which is very important in the next class, you can use square root. So SQRT, square root of above number. Yes. Yeah. For beta 1, previously we have this one, okay, for beta 2, but they require you to calculate over n and multiply by this one. So to do it, you have to create a new one called x squared. Equal, yeah, square. Uh-huh. And then do the same. Good, good. Yes, of course. And then sum it. Very good. So you finally can calculate the variance. So equal here, variance error multiplied by this one over bracket and it's 5, right? 5 multiplied by this one. X sigma x minus x bar square. And if you do it correctly, you will get 2.02. And then you calculate standard error by using the square root. You will get 1.43. In later in the next week, this number will become important. Standard error, beta, we will use it to check whether your model is reliable or not. Can you trust the number that you calculate or not? So today just know how to calculate. Okay, next week we will try to use this number. So the standard error is important. It means the fluctuation, the volatile of your data. Okay, so this is literally the standard error. If you have a small standard error, it means your forecast parameter is very accurate. So it's steep. But if your standard error is higher, your figure will become widened. It means your forecast value is not good, is not accurate. We later will use it on next week in the hypothesis testing. And if internet is lost, I'm not sure about our record. Okay, it say that still recording, so must be here. So confident interval. So both of them is for check whether you can trust your model or not. is we will next week. We will do it together to use of standard error. But this is the actual meaning. Okay, the less standard error, the less fluctuation, more reliable. The higher standard error, more fluctuation, less reliable. And the last topic today, previously we do it linear, right? Y equal of x is gone. Y equal beta 1 plus beta 2 x plus e beta 1 beta 2, right? Linear. But how about if the data is not linear? For example, this is the data of how price depends on square feet, square footage. So it means the larger of house, more expensive, right? The higher price. So this is price and square feet. And then if they have a smaller house, of course, those house must be cheaper, right? This is the common sense. Then they go to collect the data. They collect the data, and then this is the scatter. Okay, scatter plot that previously we tried to dot together, but this is the big data observation. So after we plot, we may we will use OLS to estimate this relationship. But professor, we find that there must be some like this, not the linear, right? What should we do, professor? Can we estimate this one? The answer is yes. So we have two candidates here. First, we may use, instead of x alone, we may use x square or square feet square. So first candidate model is price equal beta 1 plus beta 2 square feet, but make it square to make the chart become parabola. Or you can take logarithm. This is the logarithm. How can I write it? Logarithm. I'm not sure. Logarithm h, maybe h. So log the I don't know. I don't know the proper English. My bad. Logarithm. Logarithm. Oh, THM, no Y. Okay. Logarithm. Which means the model will become log price equal beta 1 plus beta 2 square feet. This is also produce the curve graph In each case, we will find that the slope of the relationship between price and square feet is not constant, but change from point to point. Okay, first candidate is to use the square, and then how to interpret this one. So we find the slope by using the first difference. Okay, later I will teach you how to do it. But if you write down this equation, the figure will become like this if this one greater than 0. But if this value less than 0, you will find this figure instead. But the meaning behind this is that if you estimate this one, so this one is called alpha, alpha. If alpha is greater than 0, it means the larger houses will have a larger slope and a larger estimate price per additional square foot. In the later chapter, I think it will be chapter 4 or 5, I will repeat how to read the model again and again. Okay, so this one just to make you understand, make you know that okay, they may have a non-linear relationship and we can estimate them. Also, you can make it log. Okay, so log on the left and square feet on the right. This one you have to interpret as 100 multiplied by beta percent. For example, this one is the size. So for 1 square foot increase in size, we estimate that price increase of 100 คูณ beta percent. And you may confuse that which one is better. We don't know, but we know that we have to do our best to choose functional form that first consistent with theory, second fits the data well, and then the assumptions are satisfied. I will tell you later, but let's go to Excel and see the data, and then I will teach you how to estimate nonlinear relationship. So go to Excel. Oh, I think the recording has a problem because the internet is lost, and then I forget to share the PowerPoint slide. So when you watch the YouTube, this part may be black out. Only you can only see my face like this. Yeah. But that's okay, nah? Just okay. Uh, Open your handout along with my explanation. But okay, the more important is that I already prepared the exercise to, and then I will not want you to do this step again. This step, you can do it again when you submit homework, okay, uh, to repeat the lesson. and try to understand the process when you deal with the real data. But this data, since is very big data, is more complicated. So I will show you that when you actually work on the real data, we do not need to do those step by step, but we can do it very easy. Okay, so this is square piece and this is slice, and I plot the scatter for you. And then you may see that, okay, this data, this data is cannot be linear line. It's much incorrect because the plot data show that there must be a data similar to this. So we would like to use a model to make this line. So first, you may would like to make price equal beta 1 plus beta 2 square feet square. To do it, you have to make square feet square first. So square feet SQFT square. So you equal square feet square. Yes, a lot of number, right? And do it for, so you have to copy. To copy, instead of try to drag them and very tired to do so, okay, you can just double click on the corner here, go to the corner, double click, and you do it. Okay, you can do it later on the homework, but let's try. Okay, you go to the corner, okay, click it, yeah, and then let's try to use this function equal linear. This is called linear regression. So LINEST, linear. I will try first. I'm not sure that can we click like this. No, we can. Okay, of course. Equal linear. And oh, this is become more complicated, but okay, follow me. Click at price because they would like you to put Y first. Okay, and then control over here, shift and down arrow at one or at once. Control shift together. One more time. Sure. Okay. Control shift down. Good. Okay. And second step, you have to put the comma here, comma. Okay. And then you select x data, which is square feet square. So go to C1, Control Shift, down arrow, comma, comma. Okay. Sure. Oh, oh, there. Yes, good, good. Control Shift down, at once together. Click this one first. Okay, you have to delete the backspace. Okay, click Control Shift and down arrow. You put together. Put it together. At once. Very good. Yeah. What? Okay. This is just practice. This is just practice. Okay. One more important thing that I forget is that I have to leave. If you use this formula, we do not choose the name of variable. Okay, so we must start at B2 instead. Good. So rename B2, Control Shift down, and yes. Oh, okay, then enter, and then become to number. What does this mean? It means your equation is now lies equal. This is the constant. So price equal a big number plus 0.021 square feet square. So this is the meaning. Here is constant, here is slope. We do not need to do very complicated mathematics, right? Just use this formula. Okay? This one? Okay. Let's see the problem. Mhm. Oh, yes. Oh, why is not coming? Let me check. Because this depends on the version of Excel, let me try. not available. But okay, I will. That's okay. That's okay. This is one of the methods that Excel provides. Yes, yes, of course. Actually, they have to represent to value together, but I don't know why the Excel version is not represent to data. Okay, let me check. Why? Okay, let's change the method. Let's change the method. So this is the one of the way that we can estimate our data using Excel. There are another method, but I think it's better. Okay, but to do it is have to get the add-in for the Excel first. So follow me. After you have the Excel, go to File and then Option, the left bottom one. File, Option, the left bottom option. Okay, after you see the Excel option, please go to Add-in, Add-in, and then click Go. Add-in, Go. Yes, and please check Analysis to Pack. Okay, already, then click OK. Okay, then go to the Data tab. Data, Data tab. And then click on Data Analysis on the right. Right. And let's find regression. Regression. Okay, I will help you. Regression. Yes. Yes, good. Okay, good. Yes. Okay, go to data. Go to data. No. I will. Do you want to? Just take a list. Okay. Just watch your friend, huh? No problem. No problem. Okay, I think this method will become easier. So go to regression. Then they would like you to input Y range, input X range. So click on input Y range. Since Y this means the left hand side, so you have to choose right. So click on B and click on B here. And input X, you choose square feet square. And then please check labels. Yes, including title name. So that's why we check labels. Label means our data includes the name of variables. But let me try first because it may become error. Yeah, sure. Okay, so today lesson is to make sure that Excel is not the proper program to work with regression because we try to insert all the data at once and they become error. To solve it, when you put Y range, so you have to do previous technique by click on the price, control shift down. Okay, So you cannot just select the C column. So you have to use, okay? Okay, I will help you one by one. Oh, you you get this one? Very good. I will explain. Okay, I will explain. Click OK. Click OK. Explains. Okay. X, Y, you have to reselect again. So click. Okay, click. And then you choose only B, not B and C. Okay, B, control shift down. No, no, not the right. You have to choose down. Good. Then click OK. Good. Okay. So this is the regression analysis using Excel. So you can do a research using Excel, but in the long run, when you face more complicated data, Excel is not compatible. But this is how to read this output for today. Please read coefficients. This is coefficient. So intercept is intercept, and this is your square feet square. So this model price equal intercept plus 0.0213 multiplied by square feet square. Okay, this is how to read the output. And you may think, oh, Professor Chan, they have a lot of number. What does it mean? Next week. Next week, I will teach you. All of the number then present, I will teach you through this class for sure. But for this class, you know how to read this one, coefficient. And also, they gave you standard error. Later, we will use it. But today, okay, just write down the equation. Okay, from this output, you get price equal constant plus slope. Okay, final for today. What if I would like to do a log price equal constant slope square feet? What shall I do? Okay, go to EX2. To do it, you have to build log price in Excel. So log price. So LN mean is log at the natural logarithm. So you put ln of price. Ln of price. This is the natural logarithm. Okay, and do it for all data. and then you do it again. Okay, data analysis, but this time instead of okay for log price, it is okay. That's okay. Okay, yeah. Yeah. Okay, and then do it again, but this time please use log price versus square feet. Go to data analysis, regression, select Y data, the Y must be log price.
Sorry, I don't understand.
And then X range must be square feet. If you do it correctly, you must get similar result as me. I will help you. Good. Okay. Okay, go to data. Yeah, analysis, regression. Select Y data. You have to use your new Y. Yes, yes. Yeah. Yeah. Good. 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 Yes. New X, not X square. You have to use A. Yeah. A. Good. Down. Good. Yeah. Yeah. And click OK. Yes. Good. Very good. Good job. Good job. So how to read this data? So this data is you have log price equal here intercept 10.59 plus coefficient 0.0000596 square feet. This is the meaning of the result. And then what does this one mean? This one means if square feet increase by one size, by one foot, by one square foot, by one price will increase. Okay, but if you use log, you have to interpret as percentage. So you have to multiply this number by 100. So 100 multiplied by here. So you get 0.0596%. Okay, if it's locked, you have to express as percent. Do not forget to multiply it by 100. On the later class, I will review how to read all of the model, and the exam, the midterm exam will mainly would like you to know how to read the meaning of the model. Okay. So today's lesson, starting from we have the data, right? So for the data, we try to plot the data and then estimate the equation to represent the data. Those figure, those model will make a overall error. The sigma error hat becomes zero, which means those lines can represent the data to make the overall error become zero. So today I give you two homeworks. Okay, first homework, please repeat the step, the manual, the difficult one. Okay, repeat the step to find the relationship between y and x. You may start from make the scatter plot, okay, and then try to calculate beta 2, beta 1 variance standard error, and then let's forecast it for me. If x equals 10, what y will equal? Okay, this is the first homework just to review. Second homework, this is for understanding. Okay, so a soda vendor, okay, observe that more soda are sold at the farmer, the temperature at the game is. So based on 32 home games, they estimate the relationship between soda cell. So this is cell equal minus 240 plus 8x. A, please interpret the slope and intercept. Okay, do the estimates make sense? Why or why not? So let's discuss. B, on the day when the temperature is 80 Fahrenheit, predict. Okay, let's try to use this equation to predict. C, below what temperature to predict cells zero. So you put here become zero, and so for x. D, please get a graph of estimate regression line. So I give you only two homework, so make sure that you do it beforehand, and next week before we learn a new chapter, I will give you a solution. Okay, so okay, it's time for today. So thank you for working hard and see you tomorrow ครับสวัสดีครับ